Okay, everyone, let's take a look at this graph. Okay, so on this graph, we have the graph of two different functions. We have the graph of g of x, which is this blue or purple graph here, and we have the graph of f of x, which is this sort of pink or yellowish, not yellowish, pink, reddish graph right there. That's the straight line. Okay, let's try to use this graph to answer some information. Let's say we were asked, what is the value f of 2? Okay, what if we were asked, let me try to write it better than that. What if we were asked, what is the value of f of, darn it. All right, hold on, guys. Sorry. What if we were asked, what is the value of f of 2? There we go. What's the value of f of 2? Okay, well, let's try to remember what this means. What does f of 2 mean? This means what is the output of the function f, if you input the value 2, right? What is the output of the function f if you input the value 2? Well, let's remember that when we're dealing with graphs of functions, the inputs are listed on the x-axis, that's the left to right axis. So where would be x equals 2? Where is x equals 2 on this axis? It's right here, right? X equals 2 would be right here. So if we plugged x equals 2 into the function f, what would the output be? Well, let's go up and find f of x is right here, right? So the output of f of 2 is equal to 5, right? Can everyone see that? The output of f of 2 is equal to 5. All right, let's try some more. Let's say we were asked, what is g of, let's say, -1? What is g of -1 equal to, right? Remember, that means what is the output of the function g if you input the value -1? Well, let's remember that the inputs are those values that are listed on the x-axis. So let's find the value -1 on the x-axis. That's right here, right? That's right here. So what is the value of the function f of x at this point? What is the output of g of x? What is the value of g of x at this point? Well, let's go down to the graph of g of x right here. All right, that's the output of g of x for x equals -1. And what's the value of that output? It looks like right here would be -4, right? If this is 0, this is -1, -2, -3, -4, and then -5. So g of -1 is equal to -4. All right. So let's try to answer a couple more questions, okay? What if we were asked, for what value of x, for what value of x is, let's say for what value of x is g of x equal to, let's say, +1, okay? So for what value of x is g of x equal to +1? Okay, so that means what value of x produces the output +1 for the function g, right? Okay, so remember the outputs are listed on the y-axis, right? So let's find the value of 1 on the y-axis. That's right here, right? Right here is the value of 1. And we can go see right at this point here, and also at this point here, right? At both of these points, the output of the function g is equal to 1. So what are the corresponding x values for those points? It looks like those corresponding x values right here, right? X looks like it is -3, right? So this is true for -3, x equals -3. And over here, it looks like right here, x is a little bit less than 2, right? So let's call it x equals 1.9. Okay, hopefully that makes sense to everyone. So x equals -3 produces an output of 1 for g. So that means g of -3 equals 1. And g of 1.9 just about also would equal +1. Let's try to answer a couple more questions about these functions using this graph. Let's try to answer this question. Let's try to say let's try to answer this. State 3 values of x such that f of x is greater than g of x. All right, so let's try to state 3 values of x such that f of x is greater than g of x. All right, so let's see, when would f of x be greater than g of x? That would mean that a point on the function g of x is greater than the corresponding point on the function f of x. Let's try out an example for practice. Let's say, does this condition hold at x equals, let's say, -3, okay? Does this condition hold at x equals -3? Well, let's find x equals -3 on the x-axis, okay? Let's see, what's the corresponding output for the function g of x if we look right up from that x value? Well, see here, it looks like g of -3 equals a +1, right? And what about for f of x? It looks like f of x is at that point, it looks like f of -3 is something like -4.5, but it's definitely a negative value, right? Like at this value right here, x equals -3. At this value of x, the output of the function g is definitely bigger than the output of the function f, right? So it's definitely not going to be the case at x equals -3. So at what values could it be the case? Where does g of x, or rather where does f of x have a greater value than g of x? Let me switch to a different color first of all. Well, what about this value of x right here, right? At this value of x, x equals -1. See, f of x has a greater output right here, right? Right here at this value of x, right? F of x has a greater output. At this value right here, right? F of x has a greater output. So really, at any value of x within this region on the domain, right? I know there's a lot of colors going on right now, but basically at any value of x within this region of the domain, right? The value of the function f of x is greater than the value of the function g of x. Let me get a new value of this, not a new value, but a new clean version of this graph for a minute. So at what 3 values, or at least pick 3 values for which f of x is greater than g of x. There's infinitely many, but let's pick a couple. Well, what about x equals 1, right? At x equals 1, right here, see, f of x is greater than g of x. What about at x equals 0, right? At x equals 0 right here, so you see that f of x is greater than the corresponding value of g of x. And what about at x equals -1? At x equals -1 right here, right? Now the output of f of x is still negative at x equals -1, but the output is even more negative for g of x. So at these 3 values, among many others, the value f of x is greater than the value g of x.